Good morning, Hayden. We're looking at lesson 109. So this is to use the quadratic formula to solve. So if you watched the video, which I hope you did, or looked in your workbook, which I hope you did, you would see what the quadratic formula is. It is simply whatever variable is in your quadratic equation, it's x, let me get my pen. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Where do we get the values of a, b, and c? That's the question. We get it from our quadratic equation. So the coefficient of each term in degree order, you have to put it in degree order, is going to be equal to the value of a, b, and c. So your x squared term is equal to your a. So that term that goes with the x squared is a positive 2. Your x term is equal to your b term. And in this case, we have a negative 3. You have to take the sign that's in front of the number. And then the term that does not have an x, or where we would say x to the 0, because this would be x to the 1, x squared, x1, x to the 0, which makes this a 1, which makes this go away. That's your c term. And that's the one that doesn't have the x. That is equal to negative 7. All right, so if you put them in descending order of the variable, then it's a, b, c. You got to set it up just like that, okay? So a, b, c. So we drop them in. We make buckets. We would have negative, and then you have b, plus or minus. You just make a bucket where the letter is. You don't try to include the stuff around it until after. So here's b squared minus 4 times a times c over 2 times a. Now you drop in your stuff. All right, a goes here and here. B goes here and here. And c goes here. All right, I know for a fact that this formula is in your workbook. So you don't really have a reason not to know what it is. You need to remember it. All right, so now we just solve it. We're ready to solve. We've got x is equal to the opposite of a negative 3, which is, that's what a negative says. It wants the opposite. So the opposite of negative is positive. So 3 plus or minus, and we've got negative 3 times negative 3 is 9. And then negative 4 times 2 is negative 8. Negative 8 times negative 7 is a positive 56. And all of that is over 4. So x is equal to 3 plus or minus the square root of 65. And that's all over 4. All right, you could also separate that. You could say 3 over 4 plus or minus the square root of 65 over 4. This is actually what we're working toward. This would be the most correct because you don't want to have a radical included with an actual value here. But we'll accept this in the very beginning just because that's what we're getting used to. We're learning how to solve it. So we worry about solving it first, and then we worry about format. So let's type that in. Excuse me, I got hiccups. So we would put in 3 over 4 plus or minus square root of 65 over 4. Okay, and that would be correct. Let's move on. So here we've got one that is not in the right format. So let's capture it and move it over. And I'm going to drag it in here. Let me move this up. And I moved it up too much. Let me grab it. Stretch it out. So what we have to do here is we have to put this in the right format in order to solve. So it means we've got to move this over to the other side. So that's going to be 2x squared plus 3x minus 1 is equal to 0, because that's what we get, right? So now we know what our a is. Our a is our x squared term, so that's positive 2. B is equal to positive 3, and C is equal to negative 1. So these are our values for our quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. It's always the same formula. So x is equal to, let's put in our buckets, now we drop in our b terms first, so 3 and 3. Then we drop in our a terms, 2 and 2, and finally our c term, negative 1. So now we can multiply, do all the things. The opposite of a positive 3 is a negative 3. Plus or minus square root of 3 times 3, that's 9. And we have a negative 4 times 2 is a negative 8. Negative 8 times negative 1 is a positive 8. And that's all over 4. So x is equal to negative 3 plus or minus the square root of 17 over 4, which you could also write as negative 3 over 4 plus or minus the square root of 17 over 4. Either one of those should be taken. We're going to do this one this time just to show that it will be accepted in Jupyter. So negative 3 plus or minus the square root of 17 over 4. And it takes it. All right, it would take either one of those. It takes it either single terms or combined terms until we get you trained to separate them. So that's all you're doing for these quadratic formulas over and over and over again. You're putting them in the proper order. We'll do one more. And then you're dropping it into your quadratic formula to solve it. I let it go away. I let it slide off. So let me take this screenshot and drop it in. Here's our quadratic formula. So the first thing we do is we put it in the proper order. So all of this has to come to the other side. So then this becomes 0. And then we have 2x squared. We have minus 3x and minus 10 in descending order of the x term. So our a is equal to positive 2, our b is equal to negative 3, and our c is equal to negative 10. So we have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so make your buckets. All right. Now, b goes in first, so it's negative 3, then a, 2 over 2, and then finally c, which is only used one time. Excuse me, frog in my throat. Then we do our calculations. X is equal to, the opposite of negative 3 is positive 3, plus or minus square root of negative 3 times negative 3 is 9. 4 times 2 is negative 8. Negative 8 times negative 10 is a positive 80. All over 4. So x is equal to 3 plus or minus the square root of 89 over 4. You could also write it as 3 over 4 plus or minus the square root of 89 over 4. Either one of those is correct right now. Later on, this will be the only one that's correct once we explain that. So you could type either one of these in, and then you would get that marked right. All right, that is the right answer. So what I want you to do is to use this to solve the rest of them. This is not hard. This is just substitution. The only thing that you have to remember to do is when you come over here to your Safari, you have to remember to hit your Shift key on your keyboard or to uncheck that Shift button to get back to your regular sign here. And this plus or minus sign goes after your B term. It goes after that first number. Okay, this means plus or minus. So do those. All right, let's see what else you needed help with. All right, Maureen deposited. This is from lesson 114. Maureen deposited $19,000. That's her original deposit at 11% interest compounded. What was the total interest earned in 8 years? That's the information that you need in order to solve the problem. We're going to use the compound interest formula, which is the amount in time is equal to the original amount times 1 plus the interest rate in a certain amount of time. So these two t's should be the same. And these two t's, that's the amount of periods in which it is compounded. And it says compounded annually. So it means once a year. Annually means once a year. So if you're doing it in 8 years, once a year is 8. That's 8 compounds. So the amount in 8 years is equal to the original amount of $19,000. And then we have 1 plus the interest rate. So it's 1, and the interest rate has to be converted into a decimal. It'll be 0.11. And then that has an exponent of 8, because that is the times that is going to be compounded. So we add this together. So we have the amount in 8 years is equal to 19,000 times 1.11 to the 8th power. So that's what we do on the calculator. So let me bring up the calculator. We know PEMDAS tells us to do exponents first. It tells us to do parentheses first. So we did the parentheses operation first. We added those together. Now we have one term in the parentheses and we take it to the 8th power. 1.11. We hit our exponent key to the 8th power equals that number. So we've done this. Now we need to multiply it times this. So times 19123. We have $43,786, and then we round this to cents, so that'd be 22. So 43786.22. 43786.22, and that is the amount in 8 years that she would have. But we don't want to know the total amount. We want to know the total interest earned. So we have to subtract the original amount that she deposited into the account. So I'm going to go back to the calculator and I'm going to subtract 19,000 from that number that we did. And that gives me 24,786 and 22 cents. 24,786 and 22 cents. And that's the number we're looking for. That's the amount of interest she earned in 8 years at 11% interest compounded annually. So that's what we're looking for. You have to look at what is the question asking me for? What is the problem looking for? And here it wants total interest earned, not the total amount in the account. How much money did we make over what we invested? So that would be this amount here. Okay. All right, let's look at the next one. All right, so this problem says the greens married inversely is blue squared. Obviously, that's a typo. Because they didn't marry, they varied. That's obviously an autocorrect. I must have hit R twice and it automatically corrected it to married and I didn't catch that. So I apologize for that, but a little common sense there would tell you that this is varied. And you probably already caught that because you're a pretty smart guy. Greens varied inversely. So what does that mean? When it's inversely here, that's the key word. When it says inversely, we know that that's division. So that would be greens is equal to K over B, and it says blues squared, so B squared. This is the formula that we need to use to solve the problem. So the first scenario says that when there were 5 greens, there were 50 blues. So greens, we put 5 in for green, and then we put 50 in for blue, and we square it. So first we have to get 50 squared. What is 50 squared? So 50 times 50 is 50 squared, so 2,500. So 5 is equal to K over 2,500. How do we get rid of this and solve for K? We multiply everything by 2,500. Right? So then that would cancel each other out, which would leave K by itself. So now we just have to multiply 2,500 by 5. So we pull our calculator back up and we say times 5. So 12,500 is the value of K. Now we use the same formula again for the second scenario. How many greens? Green is what we don't know, so green is our variable. We don't know how many greens. We do know what K is. It's 12,500 when there are only 10 blues. So 10 squared. All right, so G is equal to 12,500 divided by 10 times 10, which is 100. So that means G is equal to, we cancel, 125. 12,500 divided by 100 is 125. So that's how you do those inverse problems. You use division format, okay? If it is inverse, it equals division. If it is direct, it equals multiplication. And that looks like the first thing, A is equal to, sorry, it's too close to the top, K over B, and the multiplication looks like A is equal to K times B. So inverse is division, A equals K over B. Direct, this is directly, then it's multiplication, A is equal to K times B. That's our two different formats that we use for vary or proportional problems. Let's look at the next one. So this one is from lesson 115, and it says to graph the following inequalities. Well, in order to do that, we treat these like these are equal signs, and we graph the line. So this would be a line that looks like y is equal to x. So we graph that line. It does have the equal signs. That means it's a solid line. So if y is equal to x, then we have the numbers are going to be the same. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2, and so forth and so on. So this is going to be where the numbers match up, right? Those are our points where the numbers match up, -5 and -5. So it's a solid line. So we draw a solid line through those dots, and it's not always easy, but you can get really close. So that's our solid line for that one. All right, so now that we have graphed that line, we don't need that anymore. Now let's graph this line. So it looks like y, and it is equal to negative x plus 2. So we find the positive 2 because that's our y-intercept. And this is negative 1x, which means negative 1 over 1 is our slope. So that means down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, all the way. This is our angle that we're doing. So we just back up that angle. We follow that line through our points. And then it is a solid line. So we draw a solid line through them. And now we don't need this anymore. Now that we've got our line, we're done. right? So I put my arrows on my line. Now I have to figure out what area do these equal. All right, what area do I need to shade? We are shading areas. Whenever you have an inequality sign with your lines and your graphs, you have to shade the points that correspond to both of these. So we have, looking at y is greater than x. That's this first line right here. So if y is greater than means above, right? Greater than means above, and less than means below. So we need the areas that would be greater than or above this line. So that would be this area and this area, right? And it's okay to put check marks on your screen and then erase them later once you figure out the area you need. So this one means y is greater than negative x plus 2. So that's the second line. So above the second line would be this area and this area. So this area and this area. So all you have to do is shade the area that overlaps, or in this case has 2 check marks, because it is the same area for both inequalities. So we don't need this check mark because it's only used once, and this one's only used once. This one is used for both of them. That's why we've got 2 check marks here. So this is the area that we shade in. So we would take our other marker color, our yellow. You could use a black also, it doesn't matter. And just give me some squiggles in here to show me that you know this is the area that is true for both of these inequalities. And that's how you would do one of those. All right, let's see which one is next. All right, so here we have to find the equation of the line that passes through the point 1 and 3 and is parallel to y is equal to negative x plus 8. So what this does, we're looking for a line that's parallel. It has to be parallel. Let me get my pen back. So if it is parallel, that means it's going to have the same slope. So this will be the same number. So when we write the equation of the line, y is equal to mx plus b, we can copy this here. So y is equal to negative x plus b. Now we just have to find out what b is. And the way that we do that is we take the point that they give us and substitute it in. We know this is x and this is y. That is the way we write it. So we put in 1 for x and 3 for y. So 3 is equal to, this is negative 1 and x is 1 plus b. And now we calculate. 3 is equal to negative 1 times 1 is negative 1 plus b. Now we need to get b by itself in order to figure out what to put here, or here I should say. So we're going to add 1 to both sides to get b all by itself, so we know the value of b, and that gives us 4 is equal to b. So we take this b value and go right back up here and substitute it in. So that becomes y is equal to negative x plus 4, because this is a positive 4. And that would be your answer. So that's all you have to do. If it says parallel, then it's the exact same slope. So parallel equals same x. So whatever the x is here, you put that in for these terms here. Okay? That's all you have to do. All right, that was the last one for this lesson. If you have any more questions, please ask.